Dear students, we can continue the physics question paper discussion of Neet 2018. The previous two videos will give the questions till 30. Then now we can continue with the question number 31. A good question is waiting. Three objects, A solid sphere, a thin circular disk, and a ring, have the same mass and radius r. So a solid sphere, B a disk, C a ring. They all spin with the same angular speed about their own symmetry axis. The amount of work required to bring them to rest would satisfy the relation. We can say the work energy theorem. So going to rest. So we can say the present kinetic energy, that is nothing but the work done. So for a rolling body, so here the spin about the same. So that energy is nothing but equal to half I omega square. Only the rotational motion here. And hence that work done is proportional to its moment of inertia. You know, for the ring the value is mr square. For the disk as mr square by 2. For the solid sphere that is 2 by 5 m into r square. So the work done is proportional to the moment of inertia. So the ring that got the maximum. So the work done for C is greater than B than for A. So we can say the answer is the third one. A good concept. Number 32. A moving block. That concept is very important, especially the collision. A moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of the lighter block is v, then the value of coefficient of restitution will be. So simply, you know, the coefficient of restitution is nothing but the relative velocity of separation. The relative velocity of separation by the relative velocity of approach. So the after collision we can say as v2 minus v1, and before collision so we can say as u2 minus u1. So it is given the initial velocity v1 and u2 are studied to be 0, and hence we can say equal to v2 by u1 in magnitude. So v2 by u1. So it is given as u1 as v. Then how we can find v2? You can simply use the conservation of linear momentum, the very, very important concept. Before that m moves with a velocity v, so m into v, but that 4m mass is as stationary, so 4m into 0, it should be equal to after collision, that m become rest, and 4m say moves with the velocity of v to here. So we can write as v to take the value equal to mv by 4m. So we get as v by 4. So you get the value for E equal to V2. V2 is what? V by 4 into U1. U1 is V. So 1 by 4. So that is take the value as a 0.25. A good question. So we get the answer as the second choice. 33. In which one of the following statement is incorrect? Incorrect. The first choice, the frictional force opposes the relative motion. It's the right statement. The limiting value of static friction is directly proportional to the normal reaction. Surely, as mu times Fn, the rolling friction is smaller than sliding. So that is said to be the low one compared to the sliding friction or Kennedy friction. And here, the coefficient of sliding friction has a dimension of length. So, it got no dimension. So, if you just write one concept as, say, is equal to mu times of reaction, actually the frictional force. So, friction force and NR got the force dimension. So, mu is dimensionless. So, we can say 4 as the correct choice. Number 34. A good question is waiting. Simple question, but very good question. Number 34. A toy car with a charge Q moves on a frictionless horizontal plane under the influence of uniform electric field E. Due to the force QE, its velocity increases from 0 to 6 in 1 second. So we can say that a toy car is moving in the direction of electric field, say in this way. And it gains 6 meter per second at this point from 0 in 1 second. At that instant, the direction of the field is reversed. So that means the acceleration becomes surely retardation. And hence, that retardation, it must go into rest to a particular point. Okay, we can say in how much time after that. So that, it is with 1 second. So to become rest, so we can just go through the problem. Again, the car continues to move for 2 more seconds under the influence of this field. The average velocity and the average speed of the toy car between 0 to 3 seconds are respectively. So simply at first we can find what is the acceleration for the duration of 1 second. So acceleration is nothing but a 6 minus 0 by the time as 1. So we can say as a 6 meter per second square. See, for time t equal to 0 to t equal to 1 second, you can find the distance traveled as s1 is equal to the initial velocity is 0 here, and hence we can just substitute for s1 as equal to half into 6 into the acceleration into 1 square. So it travels a distance of 3 meter. Then what happened when the time interval take from 1 to 2 seconds? So there we can write as s is equal to the initial velocity, it is nothing but a 6. So 6 into another 1 second. So minus, it becomes the retardation of 6 into 1 square. So again, as a 6 minus 3 as a 3 meter. So again, so it's going to rest at a 3 meter. So again continues to that opposite direction. So it must return. Yes, so that is another concept. So when time t equal to 2 seconds to t equal to 3 seconds, the very important concept. So there S3 take the value equal to the initial velocity here, it must be 0. So 0, s minus half into that acceleration into 1 square. So equal to minus 3 meter. So it reached this point. That is a very important concept. That is the final point here. So our question is, what is the average velocity? The average velocity is what? The total displacement, that division by the total time interval. So what is the total displacement? So that is equal to S1 plus S2 plus S3. So 3 meter plus 3 meter minus 3 meter. That division by 3. So 3 cancel. So you get the value 1 meter per second. Look the next question. to find the average speed. So average speed so is nothing but the total distance, that division by the time. So we have to consider the distance without the sign. So 3 plus 3 plus 3 by 3. So you get the value 9 by 3 as equal to 3 meter per second. So you get the answer. The average velocity is 1 and average speed as a 3 meter per second as 2 as the. So it's a very good question. Uh, you must think about the motion after that. So this is a very good concept. So that is question number 34. Number 35, again a good question is waiting. A block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration A towards the right. The relation between A and theta for the block to remain stationary on the wedge is. So that is we need to find. So at first we can just think about what are the forces acting on that block. So that is a very important concept. See, we can just draw the figures there. See, so we have to account with respect to the wedge. So therefore the pseudo force acting on it, we have to think about it. See, this is a theta. The weight mg is acting here. So the weight mg. So this is mg sine theta. So what is this one as mg cos theta? The normal reaction is there. Okay, fine. But keep in mind here the another concept is our the force, external force is acting in this way. way. So the pseudo force must act in this way to the body. way. So that MA can be split into two components. So that is a very, very important concept. And if it is a theta, and hence this become theta, and this component become MA cos theta. In order to remain stationary, that MA cos theta, that is a very important concept. We have to say MA cos theta should equal to the weight component mg sine theta. So that is a concept. So there mm cancel. We can find the value for A equal to g sine theta division by cos theta. So that is nothing but equal to g tan theta. A good question. So we get the answer as the fourth choice. A good question, keep in mind. Number 36. The moment of the force that is given as here F is equal to 4I plus 5J minus 6K at 2, 0, minus 3. So we can say the final point as 2I plus 0J minus 3K. About the point, so the origin can be treated as R1 equal to 2I minus 2J minus 2K. So we have to find what is the moment of the force, the torque acting on it. The moment of force is called the torque. That is nothing but R cross F. So need to find what is R. So R is nothing but R2 minus R1 equal to. So 2 minus 2 as 0I. Yes, 0I plus 2J minus 6 minus 3 minus 2. So minus K. So equal to determinant. The value of R, that is R is 0, 2, minus 1. And R cross F, F is what? 4, 5, minus 6. So equal to I into. So I into. Yes, just crossing by applying 2 into minus 6. Minus 12. Minus minus. minus j into 0 minus, so plus 4 plus k into minus 8. So you get the answer minus 7i minus 4j minus 8k. So you get the answer as the choice 4. A simple concept. Number 37. Students, you must go through the theory part, especially the screw gauge and the vernier, the very important concept. It is a good question. A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is, so the main scale reading it is given as 0.001 centimeter, 5 millimeter. So can be written as a 5 into 10 raised to minus 1 centimeter. And 0 of circular scale division coins with the 25 divisions. So circular scale divisions as a 25. So circular scale reading become 25 into the least count. You get the value as 25 into 0.001 centimeter. So equal to 0.025 centimeter. If the screw gauge has a 0 error of, so we have to find the 0 correction. That is opposite to the 0 error. So it becomes plus 0.004 centimeter. Then what is the correct diameter of the ball? The diameter is nothing but equal to the main scale reading plus the circular scale reading plus or minus 0 correction. So that is the answer. The main scale reading is 5 millimeter. The 5 millimeter is 10 raised to minus 1 centimeter. The circular scale reading become 0.025 centimeter. The 0 correction become 0.004. So you get the answer as is equal to as a 0.529 centimeter. So you get the answer as 4, and is the very important concept. So you keep in mind, if the 0 error is given, then the 0 correction become plus. Number 38. A solid sphere that is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass the same. Which of the following physical quantity would remain constant for the sphere? So it is increased to this one, m remains the same. If there is no torque externally acting on it, keep in mind the Newton's second law of rotatory motion, that must equal to 0. That means L become a constant. That is I omega is a constant. That means angular momentum is a constant. That is a very important concept. Number 39. The kinetic energies of a planet in an elliptical orbit about the sun at positions A, B, C, R, K, KB, and KC respectively. AC, the major axis, and SB, the perpendicular to AC. And keep in mind for an elliptical orbit, this is said to be the focus. But keep in mind that the lowest location, the separation become minimum for this location, maximum become this location, and that location is said to be perihelion, and this position is said to be aphelion. So the minimum separation with the A, then become B, maximum separation for C. And you know, the aerial velocity is a constant. That is a very important concept for the planetary motion. And also the angular momentum is a constant. That is m into VR is a constant. That means velocity is proportional to 1 by r. When r decreases, velocity increases. So got the maximum kinetic energy at the point Ka. So we can say that the Ka should be greater than B. It should be greater than C. The very important concept. Number 40. If the mass of the sun were 10 times smaller and the universal gravitational constant were 10 times larger, then which of the following is not correct? The time period of a simple pendulum on the earth would decrease. The time period is nothing but equal to 2 pi into root of L by G. G is what? G m mass of earth by r square. But keep in mind, here G only changes. Mass of the sun is changing. So that is there is no effect on this equation. But G is greater. So G is become 10 times. So the time period should decrease. So that is a good correct. But we need not correct. Walking on the ground would become more difficult. There also, suppose the height we have to jump or move, that is equal to u square by 2g. So g is here. So g is here increases actually. So the weight increases. Okay, we can say that the weight mg, that weight increases, so it becomes more difficult. Raindrops will fall faster, so reason g increases, and hence that becomes more fall faster. G on the earth will not change, but g on earth is g into m by r square. Here not mass changing, but here g changes, so it is a wrong concept. So 4 as the answer. Number 41, a good question. A solid sphere is rolling. It's a very important concept. You can wait a minimum one question from this area. In a rolling motion, a body possesses the translational kinetic energy as well as a rotation. Then we have to find the translational kinetic energy by translational plus rotation. So we find the simple shortcut for translational for rotation as a k square by r square. But if you want to find what is say kt by kr, the simple relation as 1 by k square by r square. If you wanted to find as kr by kt plus kr, then it is so easy to find as k square by r square by 1 plus k square by r square. So here this is the concept. So 1 by 1 plus. What is the k square by r square for solid sphere? You know, for a solid sphere, the moment of inertia is what? 2 by 5 m into r square. So mm cancel. So k square by r square, take the value as 2 by 5. So 2 by 5. So equal to 1 by 7 by 5. So 5 is to 7. So we get the answer as 2. Number 42. A smaller sphere of radius r falls from a rest. Heat is produced due to viscous force. The rate of production, so that is very important. The rate of production of heat, so that is H by T. So I am telling us that of power, then when the sphere attains a terminal velocity is proportional to, we know that F into V. In a fluid, the viscous force acting on it is nothing but equal to the Stokes formula 6 pi eta r Vt into Vd. So again, you know, as Vt proportional to r square, so we can say that power proportional to r into Vd square, so that is proportional to r into r square square, so that is equal to r raised to 5. So that is the concept. So we can say 1 as the answer. So here the rate of production of heat, that is treated as the power, that is F into V. A good concept from a radiation. The power radiated by a black body is P, and it radiates maximum energy at wavelength lambda 0. If the temperature of the black body is now changed so that it radiates maximum energy at a wavelength 3 by 4 lambda 0, the power radiated by it becomes NB. Then the value of N is. So simple concept. At first, you should know what is the Wien's displacement formula. It is a very important concept. So from that, the maximum wavelength into temperature is a constant. For the two situations, we can written as lambda T1 should equal to lambda 2 T2. So from that, we can find simply the two temperatures ratio. So that is nothing but equal to T2 by T1. Take the value as lambda 1 by lambda 2. So what is lambda 2? So lambda 2 is given as 3 by 4 lambda 0. So you get the value as 4 by 3. So T2 by T1 take the value as 4 by 3. But you know that is Stefan's law. And based on that, the power that is proportional to the fourth power of its temperature for the two cases as P2 by P1 take the value as T2 by T1 the whole raised to 4. So we know from this relation T2 by T1 is 4 by 3. So 4 by 3 the whole raised to 4. So by solving that one, you get the value 256 by 81. So that is the answer. So we get the answer as 1. A good concept. Number 44. Two wires the made of the same material have the same oleum. The first wire has the cross-sectional area and another one 3a. If the length of the first wire is increased by delta L with a force F, then how much force is needed to stretch the second wire by the same amount? So we can write as YA, take the value as FA LA by A into delta LA. For the second case as YB, take the value as FB into LB by AB into delta A. So the very important concept here, YA and YB are same, and hence we can write as FA into LA by AA into delta LA should equal to FB into LB by AB into delta LB. So here it is given the very important concept as we needed to find what is FB, and also the same extension we have to link. So delta L cancel. So FB take the value equal to FA into LA by LB, AA by AB. So, but we here, it is with one concept. The volume remains the same. So, VA should be equal to VB. That is equal to ALA should equal to ABLB. So, that is a very important one. So, here the area data is comfortably given. That AB, it is a 3A by A. What about length? So, LA by LB, take the values equal to AB by A. So AB by A. So we know the concept again. AB is 3A by A. That is 3A by A. So A cancel. You get the value as 9F. So that is the answer. A good concept. So keep in mind the relation. It is a very important concept. We can move to the last question of 45. A good concept. A sample of 0.1 gram of water at 100 degrees Celsius and a normal pressure requires 54 calorie of heat energy to convert to steam at 100 degrees Celsius. If the volume steam produced is 167.1 cubic centimeter, the change in internal energy of the sample. A good question. We can use the first law of thermodynamics. We know as delta Q is equal to delta U plus delta W. We needed to find the change in internal energy, that is dQ minus dW. So it is given the value of dQ as 54 calorie. We can convert it into joule as into 4.18. You get the value as 225.72 joule. And is given what is the work done. It is nothing but the power the pressure into the change in volume is equal to, the pressure is atmospheric temperature, atmospheric pressure as into 10 raised to 5 into the volume change as 167.1 cc as a 10 raised to minus 6. So you get the value as 16.927 joule. So delta U is equal to 225.72 minus 16.927. You get the value 208.7 joule. So we get the answer as 2. So the very important questions. See, if we go through the 2019 and 2018, and we get one concept. If you go through the syllabus in detail and try to do maximum MCQs, then you can wait the maximum score for the NEET 2020. So God bless you. Take care.